A gigantic Tyrannosaurus rex slams into a prehistoric jungle, kicking up dust as a male African lion leaps for its neck in slow motion. Our goal is to build an 8-second visual effects sequence of this exact clash entirely from scratch, using nothing but text commands. To process these advanced cinematic instructions, you will need a capable video generation platform. Kling AI, Hailuo AI, Runway Gen 4, and Veo 3 are currently the best engines for handling this level of detail. Before feeding anything into the engine, open a blank text document. Staging your script here allows you to quickly iterate and adjust your variables without accidentally triggering an early generation. If you simply type "lion fighting a dinosaur," the engine guesses the details, resulting in messy, unpredictable hallucinations. To guarantee professional cinematic output, we have to construct a rigid 3-part architectural prompt. Step 1. Open your chosen platform's workspace and navigate to the main text-to-video input field. This block represents our base prompt. We strictly define physical action. The T-Rex slams the ground while the lion leaps. Next, we map the environment, a dense prehistoric jungle lit by a golden sunset. Finally, volumetric fog renders light interacting with air. We finish the base prompt by layering in texture. Commands like detailed fur and scales and realistic muscle movement dictate how skin reacts to lighting and exertion. By stacking precise action, environment, and texture commands, this base prompt acts as a physics engine. You are establishing mass, friction, and atmosphere before a single pixel renders. Now that the physical world is built, we have to fence it in. Locate the negative prompt field in your workspace, or use your platform's specific command syntax. First, block styles you do not want. Entering terms like cartoon or the word anime and CGI look stops the sequence from defaulting to standard animation. Second, block the structural errors that AI generation commonly produces. Explicitly list extra limbs and duplicate animals or deformed faces to force the engine to adhere to real-world biology. This split screen illustrates the difference. The left lacks restrictions, resulting in a glitched, distorted animal. The right side produces a photorealistic, texturally perfect lion. Negative constraints define what the engine cannot do. They act as a strict boundary system, ensuring the engine maintains documentary-level realism. The final procedural step is appending physical camera operating instructions to the very end of your prompt data. If you leave this out, the engine defaults to a locked-off, static shot. By typing IMAX cinematic and handheld tracking, you force the frame to move and shake with the impact, placing the viewer directly inside the fight. For establishing shots, commanding a drone fly-through adds sweeping depth, pushing the lens rapidly through dense foliage to create a massive sense of scale. Adding the command 120 FPS alongside motion blur tells the engine to calculate smoother transitions between frames. This ensures that the high-speed impact between the lion and the T-Rex stays crisp. Hit generate. The server now requires a few minutes to process the text string and compute these variables into video frames. When the playback is ready, verify 3 things. Did the lighting match the time of day? Did the physical bodies interact with accurate weight? And did the virtual camera track the motion correctly? Artificial intelligence does not naturally understand how to frame a movie sequence. It must be explicitly programmed to operate a virtual camera to get cinematic results. Here is the final output. The colossal T-Rex swings its massive tail, throwing hyper-realistic dust and debris into the golden hour lighting, shaking the earth as the predators clash. The base details gave the animals realistic weight and muscle movement. The negative filters kept the anatomy intact, and the camera direction forced the lens to track the impact perfectly. You can swap these variables to build entirely new encounters. By changing the text to a colossal Spinosaurus in a misty swamp, the engine recalculates the physics to render slow-motion water droplets, huge splashes, and thunderstorm clouds. To scale up to a multi-subject sequence, like 3 male lions fighting a T-Rex, you adjust the environment to an ancient volcanic valley. You instruct the engine to map 1 lion jumping toward the face, 1 attacking from behind, and 1 roaring on a rock, all while ash falls from the sky. With a structured base prompt, strict negative constraints, and precise camera direction, you control the variables on the screen. Take this framework, load up your text document, and start directing your own sequence.